as well, because then I'll upload my outlines
That's
too.
what I'm saying. Yeah, upload whatever you just make a folder, right? Like megas stuff.
Okay.
Videos, I think you could do like long videos on this.
This might be a 2-hour.
Look at all that spaghetti and meatballs.
Then you have to make your own account. It's gonna be too long.
Yeah, no, I think for this I might just,
Okay. We,
But I need to
This
we on the
isn't
same
mine,
page?
it's Willow. So I just asked Willow to
Oh, all right.
There's the kidney.
It's the kidney. That's low power. Under medium power, sometimes you can see these things more clearly.
What was it? Starts with a G.
Starts with a G. Yes, glomerulus. Glomerulus. Yes.
Camaradas.
Glomerulus. That's off the
Like
capillaries.
spell that.
If you get the glum part, you get
Oh, glomerulus.
75%
Glamorous
credit.
is what I will write on the thing.
I'm so mad.
Glamorous.
So the last K is K-E-Z, right?
Hey, kiss.
Oh my god.
That's my rapper name.
Okay.
All right,
This is
so
the
now-
kidney and your
So this is all what part of the kidney we're talking about here?
Oh my god.
What zone of the kidney is this?
The,
cortex.
Cortex.
Cortex, right, the outer part of
cortex.
the kidney. And I will always show you, I'm going to ask you about the outer part of anything, or the cortex of anything. I'll show you the surface of the organ. It orients you to the location, right? It's the surface that shows you it's the outer layer. Now in this case, as we move in, it starts looking more wavy, you know, and it gets into the medulla where you see sort of loops, collecting ducts, but no glomeruli, right? And then when you get into the interior, the appearance is much more sort of straight lines. This one doesn't have too much in the way of pelvis. That's about the closest, most obvious sort of pelvisy looking, you know, sort of straight or very slightly wavy lines. Certainly not tortuous or twisted. The ones that look round are where they're cut in cross section, because the pelvis, all those little collecting ducts end up turning right and going, you know, then coalescing into the ureter, right? Ureter.
The only difference between the pelvis and the medulla is that the medulla has collecting ducts as well as looping hammy.
Yeah, so the appearance is not necessarily different, but if it's going to be medulla, look for some fancy curves there. But no, the key thing there is no glomeruli. Oh, look at those two glomeruli. Got very cozy, didn't they? Very close, those two. So now we have, if you have an area where you see obviously, you know, it's kind of a lot of turns there, a lot of waves and turns, sort of like fingerprinty looking, but there's no glomeruli, and then you know you're in the medulla. Okay. Some of the kidney specimens have a lot more pelvis. This one is obviously more of a cut from the outer edge. Okay, are we done with kidney? Yes. Can you see anything from that angle? Really? Young eyes are better than mine. Okay. Now let's see what else we got.
Compact bone cartilage.
Compact bone. Let's see. Got that someplace. Human bone ground. Yeah. What the standard slide here is the cross section. So that's the one we'll use. And that.
It's fine.
Giveaway. It's all black and white, no stain needed, because you get all that really nice contrast.
This is the compact bone, right?
Huh?
The compact bone?
This is compact bone. Compact bone, the structural unit is osteon.
Structural unit is osteon.
Okay, so then what, if I ask you what structure is filling most of the field? Or
The version canal.
Well, that's an osteon. That's not most of the central part is a version canal.
You got
The version canal sometimes looks white, sometimes black, sometimes part white, part black, because it's hollow. But the hollow parts are, if they're small, they're usually filled with the bone powder, which makes them opaque, so they appear black. If the powder falls out, they appear white. Simple as that. See? So there's one that appears white. But now you know all these.
Thank you.
So the type of tissue is compact bone, not ground bone. Ground bone has to do with the way the slide's made. And each one of these black areas is a lacuna. You remember how the cells are really roundish and flat. They look like just a cross section. And the canaliculi in between, and the lacuna and the canaliculi were occupied once upon a time by osteocytes.
Can you point to the canalicula again? Can you point to the canalicula thing?
Point to the
What did you say?
canaliculi.
Yeah, I can't say it right
Spine
now.
lines.
The fine canal.
Fine lines. Means little canals.
What was the function of the canalicula?
That's the connection from osteocyte to osteocyte and ultimately to the capillaries, which are only in the Haversian canal. There's no blood in this part of the bone because blood is much too different chemically. Remember, the bone, the environment right around the bone cells is right around saturation of calcium phosphate because it's dissolving and recrystallizing the calcium phosphate. Better not be where your plasma's at. So it's a very different chemical environment, and that's why you have this blood-bone barrier, which is actually formed by the first layer of cells inside the lining of the Haversian canal. It's called the endosteum. You don't have to worry about that. Okay, so that's bone. Very easy. Everybody will recognize that's compact bone.
Compact bone.
You will recognize.
Yes.
Yes. Okay. You will recognize all of these things. You will all get 100. Let's see. Let's see how that works out for us. Huh? Maybe. That would be nice. Okay, next we have cartilage, which you already saw. So I don't think we need to see another version of cartilage.
The things in the cartilage is called chondrocytes.
Chondrocytes are cartilage cells, yes. If you want, this, here's one by the way, that you notice. You'll recognize it's the same deal.
Okay. Can you put in memory cards into
Right? Still looks like cartilage. Whether it was from the lung or from wherever this is from, cartilage looks like cartilage. Cells with a lot of space in between, that's same sort of uniform pinkish purplish color.
Then you just move it onto a computer.
Alright, so that's cartilage.
Put it on, well, I was not going to do it on my...
And 16, 17 we got muscle.
I don't know. But wait.
Muscle.
Just transfer it to a computer
So,
and transfer and make a copy and pass it back. And you can just hold on to that and do whatever you want to.
Okay. So then I'll be able to put that in my computer? Yeah. Okay.
well, that tissue looks pretty smooth.
The smooth.
Smooth. Not smooth tissue, smooth muscle tissue. And I may show you the context of the longitudinal versus circular muscle in the small intestine. They look different because one is with the grain, one is against the grain. So, like a piece of wood looks different with the grain than against it. But basically, this is what gives it away. It looks very smooth.
They're very long cells.
They're very long. They're not nearly as long as striated muscle cells, but they may be, a millimeter long. A striated muscle cell could be close to a meter long. A little different. All right, so where would you find smooth muscle?
We must have like the intestines and things like that.
Intestines and things like that.
Involuntary.
Yes, involuntary, but not the heart. The heart's cardiac.
Cardiac. Yeah.
Okay, but we're not going to be looking at cardiac. We're just going to be looking at smooth and striated. That's looking striated to me. All right, so that's another one you should not miss. Tissue type, striated muscle. And by the way, these are nuclei cells. Striated muscle, and the functional unit of striated muscle is the sarcomere, and name one of the contractile proteins, filamentous proteins.
Actin and
Actin and
myosin.
myosin. Okay, those are typical ancillary questions asking you about those. Okay? Moving right along. I mean, you all still have those things up there. It's like you still want to get some more footage. I don't know whether we have to change it. Okay.
But that's as close as we're gonna get to the striated muscle. You're not gonna zoom in more, or higher.
No, that's high power.
Yeah.
That's high enough, and I will zoom in that much, because if you don't go to high power, you can't see the striations, because the magnification can't resolve the lines. So that would be very sneaky.
Is there anything